Hello and welcome to the channel, Statistics Decoded. This channel is for everyone who is keen to master the art of statistics but find it difficult to understand. We teach statistics in a simple way with sufficient real-life examples. In the previous module, you have learnt about the major measures of variability such as variance, standard deviation and range. Now let us learn what normal distribution is. In addition to normal distribution, measures of divergence from normality, such as skewness and kurtosis, are also explained. You will have a thorough understanding of descriptive statistics when we complete these 4 videos. If you haven't gone through the remaining 3 videos, watch them first and then come to this video. Those videos are 1. Types of data, 2. Measures of central tendency and 3. Measures of variability. After watching this module, you can clear doubts by posting it in the comments section. What is data distribution in statistics? Data distribution is the way a set of data is spread out across a range of values. It is a statistical concept that describes the frequency or probability of different values occurring in a dataset. What are the types of data distributions? There are 2 main types of data distributions: discrete distributions and continuous distributions. What are discrete distributions? Discrete distributions are data distributions that can only take on certain values, such as the number of people in a class, or the number of flips of a coin that result in heads. What are continuous distributions? Continuous distributions are data distributions that can take on any value within a certain range, such as human height or weight. Examples of data distribution. Here are some examples of common data distributions. Normal distribution. The normal distribution is also known as the bell curve. It is a symmetrical distribution with most of the data concentrated around the mean. Many natural phenomena, such as human height and weight, are normally distributed. Uniform distribution. The uniform distribution is a distribution in which all values are equally likely to occur. For example, the distribution of the number of petals on a flower might be approximately uniform. Binomial distribution. The binomial distribution is used to find the probability of success in a series of independent trials. For example, the binomial distribution could be used to find out the probability of getting 10 heads in 100 flips of a coin. Poisson distribution. The Poisson distribution is used to find the number of events that occur in a fixed interval of time or space. For example, the Poisson distribution could be used to find out the number of cars that pass through an intersection in a given hour. Why data distribution is important? Understanding the distribution of a dataset is important as it can help us to identify outliers and anomalies in the data. Make predictions about future values. Choose the appropriate statistical tests to analyze the data. For example, all parametric tests such as t-test, ANOVA, Pearson correlation are based on the assumption that the data is normally distributed. Interpret the results of statistical tests accurately. What are outliers? Outliers are extremely high or low values in a dataset. The term outlier is repeated many times in this video. In the next video, you will learn what outliers are and how to find and treat them. From among these data distributions, the most used data distribution is the normal distribution. The most used data distribution is the normal distribution, which is also known as the Gaussian distribution or the bell curve. It is a continuous distribution that is characterized by its symmetrical, bell-shaped curve. Most of the data in a normal distribution is concentrated around the mean, with lesser and lesser data points as you move away from the mean. The normal distribution is used in a wide variety of fields, including statistics, academic research, machine learning and finance. It is often used to analyze data that is continuous and has a wide range of values, such as human height, weight and test scores. The normal distribution is the most used data distribution because it is a versatile and powerful tool for modeling and analyzing data. What is normal distribution? While collecting and analyzing data, early statisticians found that an interesting pattern is repeatedly occurring in the distribution of continuous data. They found that data near the mean are more frequent in occurrence than data far from the mean. It was Abraham de Moivre, 1733, who first discovered the normal distribution, which was used by Laplace in the year 1783 to study measurement errors. Later, in the year 1809, Carl Friedrich Gauss popularized this distribution by using it in the analysis of astronomical data. Thus, the normal distribution is also called Gaussian distribution. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that is symmetrical around the mean, which means that data near the mean are more frequent in occurrence than data far from the mean. Extreme values in both tails of the distribution are very unlikely. The normal distribution is defined by two parameters, the mean and the standard deviation. The mean is the average value of the distribution and the standard deviation is a measure of how spread out the values are around the mean. Examples of normal distribution. The importance of the normal distribution, bell curve, is due to the fact that the distributions of many natural phenomena are at least approximately normally distributed. For example, take the height of a population. The height of men in a population is normally distributed, which means that the height of majority of the men will cluster around the mean and only the height of very few men will be either very high or too low. This is the case with weight, systolic blood pressure in healthy adults, IQ score of students, crop production per acre and many more such phenomena. That is, when there are many independent factors that contribute to some phenomena, the end result may follow a Gaussian or normal distribution. For example, height of people is influenced by genetic, environmental and nutritional factors. Similarly, IQ score is also influenced by home environment, education, availability of learning resources, healthcare and nutrition. This normal distribution is a major advantage for statisticians. Normal distribution allows one to collect data of a small percentage, sample, from a large group, population, and generalize the findings from this small percentage to the entire group from which the sample was selected with accuracy using the mean and standard deviation. For applying the findings from a normally distributed sample on the population must also be normally distributed. That is, if the underlying population is not normally distributed, generalization of the findings from a normally distributed dataset on the population will not be accurate. Application of normal distribution. Here is a simple example of application of the normal distribution in statistics. Suppose you are interested in the heights of all adult males in Kerala. You measure the heights of 1000 adult males and find that the mean height is 69 inches and the standard deviation is 3 inches. You can then use the normal distribution to model the heights of all adult males in Kerala. Here, the 1000 adult males is the sample and all the adult males in Kerala is the population. The normal distribution tells you that 68% of all adult males in Kerala are between 66 inches and 72 inches tall. It also tells you that 95% of all adult males in Kerala are between 63 inches and 75 inches tall, 98-95:99 rule or 3 sigma rule. This generalization of the findings from the 1000 adult males on the entire population of adult males becomes accurate because the height of adult males in a population is normally distributed. If the height of people is not normally distributed, this generalization may not be accurate. A bell curve of a normal distribution is presented here. The normal distribution can be represented using a bell curve or Gaussian curve. The bell curve shows that the data are peaked at the center, that is mean, and tapering on either side symmetrically. It derived its name from its bell shape. A normal distribution will have the following 5 properties. 1. It forms a bell-shaped curve. 2. Symmetry. The normal distribution is symmetrical around its mean, which means that half of the values fall below the mean and half fall above the mean. 3. Uniqueness. It is defined by the mean and standard deviation. 4. The mean, median and mode will be the same. 5. Empirical rule. The data will be distributed approximately in a 68-95:99.7 pattern, which is known as 3 sigma rule. A bell curve generated using the test scores of 16 students is presented here. The bell curve shows the distribution of the data set with mean, median and mode values as peak at the center with low and high values tapering off symmetrically on either side as a bell-shaped curve. This indicates that the data is normally distributed. The mean, median and mode are the same. The normal distribution is defined by the 68, 95, 99.7 rule, which is also called empirical rule or the 3 sigma rule. If your data follows a normal distribution, you can expect that approximately 68% of the data points will fall within one standard deviation of the mean. Approximately 95% will fall within 2 standard deviations of the mean, and approximately 99.7% will fall within 3 standard deviations of the mean. That is, almost all data points fall within 3 standard deviations. Using normal distribution, in real-world data, do not expect an exact reproduction of the 68, 95, 99.7 rule. You will get a close approximation of the same if your data is normally distributed. Because, in real life, you cannot expect a perfect symmetry as shown in the bell curve. However, you can use it to predict the distribution of the population from your analysis. For example, you have selected 1000 adult males from a population of adult males in Kerala and found out that the average height of these adults is 170 centimeters and the standard deviation is 5 centimeters. You can use the 68, 95 is to 99.7 rule to predict that approximately 68% of adults in Kerala will have a height between 165 and 175 centimeters. Approximately 95% of adult males in Kerala will have a height between 160 and 180 centimeters, and approximately 99.7% of adult males in Kerala will have a height between 155 and 185 centimeters. The 68, 95, 99.7 rule or 3 sigma rule can be further illustrated as in the table provided here. Since half of the values in a normal distribution are below the mean and half of the values are above the mean, the distribution can be split like this. The height of 34% of adult males in Kerala is between the mean height of 170 centimeters and 165 centimeters. That is, between mean and mean minus 1 standard deviation. The height of 34% of adult males in Kerala is between the mean height of 170 centimeters and 175 centimeters. That is, between mean and mean plus 1 standard deviation. That is, the height of 68% of adult males in Kerala is between 165 centimeters and 175 centimeters. That is, between mean minus 1 standard deviation and mean plus 1 standard deviation. The height of 13.50% of adult males in Kerala is between 165 centimeters and 160 centimeters. That is between mean minus 1 standard deviation and mean minus 2 standard deviations. The height of 13.50% of adult males in Kerala is between 175 and 180 centimeters. That is between mean plus 1 standard deviation and mean plus 2 standard deviations. That is, the height of 95% of adult males in Kerala is between 160 centimeters and 180 centimeters. The height of 2.35% of adult males in Kerala is between 160 centimeters and 155 centimeters. That is between mean minus 2 standard deviations and mean minus 3 standard deviations. The height of 2.35% of adult males in Kerala is between 180 centimeters and 185 centimeters. That is between mean plus 2 standard deviations and mean plus 3 standard deviations. Thus, you can see that the height of 49.85% of adult males is between 155 centimeters and 170 centimeters, below mean, and the height of 49.85% of adult males is between 170 centimeters and 185 centimeters, above mean. Thus, we can conclude that the height of 99.7% of adult males in Kerala is between 155 centimeters and 185 centimeters. Remember, this rule is a close approximation. In real life, the distribution of height of adult males may not show such a perfect symmetry. However, you can apply this rule when dealing with normal distribution because normally distributed continuous variables may show more or less similar symmetrical distribution. An example of how normal distribution helps t-shirt manufacturers to estimate the size category is presented here. You can see that the percentage of t-shirts produced is high in the large category followed by medium and very large. As it moves away from the center, the percentage reduces drastically because very few shirts will be too small or too large. Remember 68, 99, 99.7 rule. What is standard normal distribution? The standard normal distribution, also called the Z distribution, is a normal distribution with a mean of 0 and a standard deviation of 1. It is a special case of the normal distribution that is used in many statistical applications. Any data point, x, from a normal distribution can be converted to the standard normal distribution, Z, with the formula Z equals x minus mean divided by standard deviation. Z for any particular x value shows how many standard deviations x is away from the mean. For example, if 1.4 meter is the height of a student where the mean for students of his age is 1.2 meters with a standard deviation of 0.4 meter, then Z equals 1.4 minus 1.2 divided by 0.4 equals 0.5, that is, the student is half a standard deviation away from the mean. Another application of standard normal distribution. Suppose we want to know the probability of a student scoring higher than 80 on test. We know that the test scores are normally distributed with a mean of 75 and a standard deviation of 5. To calculate the probability, we first need to standardize the score of 80. To do this, we subtract the mean of 75 from the score and then divide by the standard deviation of 5. This gives us a z-score of 1.00. 80 minus 75 divided by 5 equals 1.00. We can then look up 1.00 in a standard normal table or Z table and find that the probability of a standard normal variable being less than 1.00 is 0.8413. This means that there is an 84.13% chance that a student will score higher than 80 on the exam. Important points about normal distribution. The normal distribution, Gaussian distribution, is the most used and popular distribution. It is defined by two parameters, the mean and the standard deviation. Many phenomena such as height, weight, IQ score and test scores follow a normal distribution. Income, housing price and similar data distributions do not follow a normal distribution as there is high disparity. Normal distribution is characterized by 68/95 is to 99.7 rule, 3 sigma rule. Parametric statistical tests such as t-test, ANOVA and Pearson's correlation are based on the assumption that the population distribution is normal. If the distribution of the data is not normal, you should use median instead of mean and opt for non-parametric tests such as Mann-Whitney U-test. Testing normality of your data is very important before proceeding to use statistical tests. Measures of divergence from normality. You have previously learned the other two measures of descriptive statistics which are given in the two previous modules. Now, the last part of descriptive statistics is measures from divergence from normality. What are measures of divergence from normality? Measures of divergence from normality are statistical measures that describe how different a dataset is from a normal distribution. They are used to identify datasets that are not normally distributed, choose the right statistical tests for a dataset, interpret the results of statistical tests correctly. As you know, a normal distribution is a probability distribution that is symmetrical and bell-shaped. Most of the data in a normal distribution is concentrated around the mean, with fewer and fewer data points as you move away from the mean. Measures of divergence from normality help us to find out whether the dataset is violating this normality assumption. The two measures of divergence from normality are skewness and kurtosis. What is skewness? Skewness is a measure of the asymmetry of a probability distribution. A normal distribution is symmetrical, with equal numbers of data points above and below the mean. A skewed distribution has more data points on one side of the mean than the other. What is kurtosis? Kurtosis is a measure of the tailedness of a distribution. Tailedness refers to how often outliers occur. A distribution with high kurtosis has fatter tails, meaning that there are more outliers. A distribution with low kurtosis has thinner tails, meaning that there are fewer outliers. Kurtosis is a measure of tailedness, not peakedness. There are two types of skewness, positive skewness and negative skewness. Positive skewness or right skewness. A positively skewed distribution has more data points on the left side of the mean than on the right side. This means that the majority of the data points are lower than the mean. In a positively skewed distribution, the mean will be greater than the median and mode. Income distribution is one example of positive skewness. Most people earn a modest amount, but some millionaires and billionaires extend the right tail into very high values. Another example is house prices. Most houses are modestly priced, but some of the houses are very expensive. Negative skewness or left skewness. A negatively skewed distribution has more data points on the right side of the mean than on the left side. This means that the majority of the data points are higher than the mean. In a negatively skewed distribution, the mode will be greater than the median and median. Example of negative skewness: scores of an exam that is easy. While most students score very high marks, very few students score very low marks. Although a theoretical normal distribution can have zero skew, real data almost always have at least a bit of skew. However, if a distribution is close to being symmetrical, it usually is considered to have zero skew. A skewness value between -1 and +1 is considered excellent, while a value between -2 and +2 is generally considered acceptable. Values beyond -2 and +2 are considered indicative of substantial non-normality. Types of kurtosis. There are three types of kurtosis. Mesokurtosis. Normal distributions have a kurtosis of 3, so any distribution with a kurtosis of approximately 3 is mesokurtic. Leptokurtosis or positive kurtosis. A positively kurtotic distribution has more data point s in the tails and less in the middle than a normal distribution. This means that the distribution has more outliers. Leptokurtic distributions have kurtosis more than 3, and excess kurtosis of more than 0. Platykurtosis or negative kurtosis. A negatively kurtotic distribution has less data points in the tails and more in the middle than a normal distribution. This means that the distribution has fewer outliers. Platykurtic distributions have kurtosis less than 3, and excess kurtosis of less than 0. A excess kurtosis of -2 to +2 is acceptable to consider a dataset as normally distributed. Conclusion. Measures of divergence from normality help us in finding out whether outliers are present in our dataset. Outliers are values that are much smaller or larger than most of the other values in a data set. You can find, remove, replace or retain outliers through different methods and make your data normally distributed. But this should be done with utmost caution. How to find and treat outliers will be explained in the next module. A skewness of -2 and +2 and an excess kurtosis of -2 to +2 is acceptable to consider a dataset as normally distributed. This may vary according to your area of research. As you have learned, testing normality of your dataset is very important to decide on further statistical analysis. Here is an example data which illustrates how to test normality of your dataset. The descriptive statistics reveal that the mean, median and mode are more or less the same. The skewness and kurtosis are also within the limits. So, the data is normally distributed. Thus, you can say that the descriptive statistics reveal that the data is normally distributed. Normality tests. What are they? Though mean, median, mode, skewness, and kurtosis can provide some indication of whether a distribution is normal, they are not enough to definitively test for normality. While these descriptive statistics can provide some clues about normality, they are not a substitute for formal normality tests. There are a number of statistical tests that can be used to assess normality, such as the Shapiro-Wilk test, suitable for sample size of less than 50, and the Kolmogorov-Smirnov test, suitable for sample size of greater than 50. These tests are more sensitive to departures from normality than descriptive statistics alone. How to interpret normality tests? If the p-value is greater than 0.05, the dataset is normal. If the p-value is less than 0.05, the dataset is non-normal. Since our dataset is below 40 students, Shapiro-Wilk test was done. The test value is 0.965 with a p-value of 0.255. This p-value is greater than the significance level of 0.05 and hence the value is not significant. Thus, we can conclude that our data is normally distributed. Conclusion. The data is normally distributed and hence we can use the mean and standard deviation. Parametric tests such as t-test and ANOVA can be used for analyzing this dataset. Importance of verifying normality of data. Understanding the data. Assessing normality provides insights into the characteristics of the data and can help identify potential outliers or biases. This understanding is crucial for interpreting the results of statistical analyses and making informed decisions based on the data. Accuracy of statistical inference. Numerous statistical tests, such as t-test, ANOVA and Pearson's correlation rely on the assumption of normality in the underlying population distribution. If the data is not normally distributed, the results of these tests may be inaccurate or misleading. Now reinforce what you have learned in this module with some questions. The right answer is also provided. Thank you. If you find this video interesting, please comment, share and subscribe for more videos like this. Thank you. In the next video, the various techniques to detect and treat outliers are detailed. Watch.